Avogadro's number. How big is this number really? In this example, I'm going to try to convey the hugeness of this value. And the way I'm going to do it is by presenting the planets in our solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Now, these planets, they do have a volume associated with them, and they're roughly drawn out to represent their various sizes. As you can see, the last four are a lot bigger than the first four, and Mars, Earth, Venus have roughly the same size, whereas Mercury is a little bit tinier. All right, so this is what I'm going to present: the volume of the planets. If you base it on the volume of Earth, in other words, divide the volume of each planet by the volume of Earth, you get ratios that tell you roughly, compared to Earth, how big these planets are. So Mercury is actually a lot smaller than Earth. It's a fraction of the, the volume of Earth, 0.06 at most. Venus is roughly the size of Earth. Mars is only a tenth of the size of Earth in terms of volume, but then Jupiter and Saturn, the gas giants, they are 1,000 times more, 700, 800 times more massive in terms of volume. All right, so you might be kind of wondering where I'm getting with this. Well, this is the idea. If you add up all the volume that we have in our solar system available, just from the planets, no moons, just the planets, we have, roughly speaking, 22,001, if you want to be, I guess, technical, Earth volumes of space. All right, so this is what I'm gonna do. I'm gonna assume, now, based on the fact that we have about 7 billion people on Earth, I think, could be wrong, but I think we could possibly fit 100 billion people, but this would be like everybody living like sardines. Like, there's no space between you and the next person, and we're all just packed like sardines in all the space available on Earth, including the ocean, by the way. So you'll have people living in the ocean, like living like sardines. Obviously, a ridiculous premise, but seems plausible in terms of the space that could be occupied by human beings. Okay, so 100 billion people we could have on Earth, let's say, in that volume of Earth, 100 billion people. And let's also go with the ridiculous premise that we can actually have people living in all of the planets. That's not going to happen, because Jupiter and Saturn have atmospheres that are just not friendly to humans, and the pressure of Jupiter and Saturn will probably crush us anyway. So this is a ridiculous premise, but you'll see where I'm going with it. So 100 billion people per Earth. Let's say that we can put people in all of the planets, and on top of that, for everybody who has to relocate from Earth into the other planets, we're going to give them $1 billion. So now everybody's going to be a billionaire. And now I'm going to ask the ridiculous question of how much currency, how much money is floating in this entire solar system. And this is a conversion problem at the heart of it all. We know that we have a total of 22,000 Earths volumes available to us. And we know that for every Earth volume, we can feed a total of 100 billion people, or 1 times 10 to the 11th people. We also know that each person is going to be given $1 billion, or 1 times 10 to the 9th dollars. So what we find out here is that if we multiply all these numbers together, we end up finding a total of 2.2007 times 10 to the 23rd dollars in the entire solar system under these ridiculous assumptions. And the amazing thing is that in all the vastness of the solar system, in all that volume occupied, basically filled up with human beings, packed like sardines, and everyone being a billionaire, even under that ridiculous premise, we still come out short of Avogadro's number. That's how huge a number this is. And yet, in 18 milliliters of water, as ridiculously small amount of water, right? Like we drink a lot more than just 18 mLs of water, but that's a small amount of water. In 18 mLs of water, we have Avogadro's number worth of molecules present. Now, if that's not mind-boggling, I don't know what is. But hopefully with this exercise of conversions, this gives you an idea of the vastness of Avogadro's number and allows you to kind of see that, yeah, you have a lot of molecules present in a batch in 1 mole of sample. Okay, so with this, we are done with this discussion, and I will see you in the next video.